Hey guys, welcome back to my YouTube channel. Today we are going to build an exciting coding project where we will build an image classifier using TensorFlow and Keras. And we will walk through each step of the process from data augmentation to model training, and then we will be evaluating the model performance. So make sure to stick around until the end to see our classifier in action. If you enjoy machine learning or deep learning and data augmentation techniques, then do not forget to hit that subscribe button and ring the bell so you never miss an update from our channel. In this project, our goal is to create a machine learning model that can classify images into horizontal or vertical categories. To achieve this, we will follow some steps. First step is data preparation and augmentation. So in this step, we will generate augmented images by mirroring different halves of the original images. And then we will start model building. That is like we will create a CNN using TensorFlow and Keras, and then we will be training the model. That is like we will train the model with the augmented data, and then we will be evaluating the model performance on a validation data set. And then at the last, what we will be doing is that we will be developing an classification function based on the model trend, and then check if our model is performing well or not. So first step towards building the this project is that we will have to import some important libraries. Some of them are like OpenCV, and then NumPy, and then TensorFlow, and we will, from Keras models, we will be importing sequential model, and then from Keras.layers we will be importing 2D layers, and max pooling 2D layers, and then flatten, and then dense and drop out some things related to that. And from sklearn dot model selection we will import like a 10 test split. So let's run this. And in the next section, what we will be doing is that we will be defining some we will be defining our folder structure of this project. That is like I have imported like a input directory, and then output directory, and then like a output directory for the vertical trend data, and then horizontal trend data, and then for the horizontal validation data, and the vertical training data, the validation data, sorry. And then we will be creating these directories. And the first function here is that like we will be creating that intends to create top half of the image, and then mirror that, and then creating a new image from that. And the same here, this function is to like mirror the bottom half of the image, and this function is to mirror the left half of the image, and this function is to mirror the right half of the image. So these functions take an image and create a new image by mirroring either the top, bottom, left, or right half. And the next, we will use these functions to create augmented images, and then save them into our training and validation directories. I have created a function to process images, and then create four augmented images. So let's break down this code. First of all, this code like a list of all image file names in the input directory, and that have dot dot png format, or dot jpg format, or dot jpeg. And then images are shuffled, and to ensure a random distribution when splitting into like a training and validation. And the total number of images are split into two data sets, 80% of training sets, and then 20% into the validation set. And in this function, in this code, what it is that it this function iterates over the all images, and for each images it constructs the full path and opens the images using the PIL library. And then it creates augmented images using the mirror top half function, and the mirror bottom half, and then mirror left half, and then mirror right half. And each function mirrors a specific half of the image and returns the augmented image. Based on whether the image file name is in the a training set or validation set, it assigns the appropriate base directories for saving the augmented image. And the here base file name is the original name of the original name of the image. And then it extends by the mirrored whether the image is mirrored, top mirrored or bottom mirrored or left mirrored or like right mirrored, and based on that each file name is like decided. And then at the last, what we do is that we print and like a completion message, so that like we know that so that we know that our data augmentation process has completed. So let's run this code. And as we can see here that it's running, and we will see here we will see here that in two new folders have been created, like a train and then validation. And as we can see here that uh, our process has completed for the data augmentation. And now let's start with the like model building. So this code is to build like a classifier based on the our image augmented image data. And then we will be training the model, and then we will be building a classifier. So let's break down and explain the code for the neural network model in the context. So in this code, I have defined the data augmentation and normalization for the training, and the same has been done for the validation. And then I have generated the validation data. And then I have built a machine learning model, or you can call CNN model, and then compile the model. And then I have saved the model, and then I have created the evaluation of this model. So let's break down and explain the code for building and training and evaluating the CNN model for image classification using a TensorFlow and Keras. So in this section, I have imported some libraries that are necessary for building our classification model. And then I have defined directories for the same purpose, that is importing the data from train directory and validation directory. And then I have created data generators using train generator and validation generator. Using the train data gen I have created here, and same for the validation data generator. And here, flow from the directory method generates batches of augmented data from the specified directory. It automatically infers the class labels from the directory structure. And now in this code snippet, I have built a model, that is sequential model. So this code defines the architecture of the CNN model using a, it consists layers with ReLU activation function, and then followed by max pooling layers. Like a layer has convolutional layer followed by activation layer, and then I have applied max pooling, and then again ReLU activation function, and then again max pooling, and the same goes on. And at the end of this model, I have applied sigmoid activation function, and that is output layer of our CNN model. Then I have compiled this model for the using the Adam optimizer. And then loss has been set to the binary cross entropy, since we know that our model is a binary classification. So that is what it has been set to. And then matrix that will be used during the model training will be accuracy. Now here I am fitting our model on the training data. So here dot fit method trains the model on the training data. It specifies the number of epochs, steps per epochs, and then validation data, and the validation steps as well. After training, the model is saved to a file name augmented image classifier.h5. After that, the model is evaluated on validation data, and validation accuracy is printed. So let's start training it. As here it has printed that 320 images has been stored in training data, and 80 images have been stored in validation data. And now our model is being trained, and we will get back to here once the training has been finished. And until now, if you have not subscribed and you are still watching, then do not forget to subscribe my channel and comment your views on the video. And as I'm starting, so please bear with me. And the video quality might not be good at this time, but please make sure you subscribe my channel, and in that way I'll be keep improving the quality of these videos. So now welcome back, and as we can see here that our training has finished. So in this code we prepared the data for training using data augmentation and normalization, and then we defined the CNN model architecture, and then we defined a CNN model architecture, and then compiled the model using the Adam optimizer, and then setting the loss function, and then we trained the model and saved the trained model, and then evaluated its performance. So this code serves as the core implementation for the image classification project that is being explained, and providing a practical demonstration of building and training a CNN model for image classification task. I'll be creating a like a classification function based on the model that I have saved here after training, and then I will pass an image and check if the image belongs to that class or not, and based on that we will be checking the practicality of our model. First of all, I have imported libraries, and then I have created a function classification classify image. So in this function I have passed the image path for the individual image, and then the model path for the pretend model that I trained earlier, and then this function loads the model from the a model path, and this code loads the image from the image path, and its target size has been defined predefined 150 cross 150, and then it has been converted to a image array, and then I have expanded its dimensions, and then I have normalized the image. What I will do is that I have passed this image array to the model, and then dot predict function has been used, and then it generates the class probability for each image. Probability is 0 less than 0.5, then it has been decided to that it is horizontal, otherwise it will return the vertical. And now let's check if our model performs properly or not. As we can see here that I passed an image from the a vertical data set, vertical validation data set, and then it has predicted that the image belongs to vertical. And the same goes for the here I have defined the horizontal image, and let's go to horizontal folder and then select one image from there. It will be horizontal, and let's see, as we can see here that the image has been classified as horizontal. So in this code we have defined a function that takes a single image file path and loads a pretend CNN model, and preprocess the image and predicts its class and returns the predicted class label. So this function serves as a practical tool for classifying images using a trained model as demonstrated. So with this single image classification function, we can easily classify new images using our a trained model. And there you have it. We have successfully built an image classifier using TensorFlow and Keras, complete with data augmentation and evaluation. I hope you found this tutorial helpful and important. If you did, please give me a thumbs up and share it with your friends, and also let me know in comments what other projects you would like to see. And thanks for watching, and happy coding.